Every single time you tap a link, you're basically unleashing this invisible, high-speed messenger on a journey that spans the entire globe. Today, we're going to pull back the curtain on the hidden story behind just one of those clicks. We are going to follow that messenger, a single packet of data, from the very second it's created all the way to its destination and all the way back. So, let's trace the journey. I mean, really think about it for a second. You click, and almost instantly, a web page from a server that could be thousands of miles away just loads on your screen. What in the world is happening in that tiny fraction of a second? Well, it's not magic. It's one of the most complex and honestly elegant ballets in all of modern technology. And we're going to break it down step by step. So before our little piece of data can even think about starting its trip, it needs to be packaged up properly. It can't just wander out onto the internet unprepared. This first stage is all about getting the message ready for its long journey, kind of like carefully packing a suitcase and making sure it has all the right labels and instructions. And the key process here has a name. It's called data encapsulation. Basically, your data gets wrapped up in multiple layers of information. And each layer adds a very specific set of instructions that tells all the network hardware how to handle it. You can think of it like putting a letter into an envelope, then putting that envelope into a shipping box, and then slapping a label on that box. This whole packaging process is organized by a framework called the OSI model. And probably the easiest way to think about it is like an assembly line in a huge company with 7 different departments. As you can see, our data starts at the very top, at the application layer, that's your web browser, and it works its way down. At each stop, like the transport and network departments, a new piece of info gets added, like a shipping label or a routing slip, before the physical department at the bottom finally sends it out as ones and zeros. Each department has one specific job to do to get that message ready to go. Now, here's something that's really important to get. At these key stages of the packaging process, the data actually gets a specific name. So when the transport layer adds its information, we call it a segment. Then the network layer wraps that up, creating what we call a packet. And finally, the data link layer creates the final frame, which is the thing that's actually ready for travel. Okay, but before any of your actual data gets sent, your computer needs to make sure it has a reliable connection. And it does this with a neat little process called the TCP three-way handshake. It's basically like a very polite phone call. Your computer sends a SYN packet, which is like, hey, are you there? The server on the other end replies with a SYN ACK, which means, yep, I'm here and I hear you. Then your computer sends one last ACK to confirm, awesome, I'm going to start sending now. This little handshake makes sure the connection is solid before any important data starts flying across the internet. All right, our packet is all dressed up, the connection is open, it's ready for the very first leg of its journey, getting from your computer through your house or your office, right to the edge of your local network. Now, to navigate anywhere, you need 2 kinds of addresses. You've got the IP address, which is the big picture, global address. Think of it like the city and zip code of the server you're trying to reach. But for local delivery, just getting from your laptop to your router, you need something called a MAC address. Think of this as the unique serial number that's literally burned into every network device. It's like a specific house number on a specific street. So, this brings up our first little puzzle. Our packet knows the IP address of the destination server, which could be on the other side of the planet. But to even get started, it needs the physical MAC address of its very next stop, your local router. So, how does it find it? You're not going to believe this. It shouts. Using a process called the Address Resolution Protocol, or ARP, your computer sends out a broadcast message to every single device on your local network. It's basically yelling out, hey everyone, I'm 192.168.0.2, and I'm looking for whoever owns 192.168.0.3, which should be the router. Who is it? Now, all the other devices on your network, your phone, your smart TV, they all hear this shout, and they just ignore it. But the router recognizes its own IP address, and it sends a reply directly back to your computer. It says, hey, that's me. My physical MAC address is 00:0B:DB:99:D3:58. And just like that, your computer has the exact address it needs for the next step. So, armed with the router's MAC address, your computer sends the frame to your local switch. Now, the switch acts like a local traffic cop. It looks at the destination MAC address on that frame, and it knows exactly which physical port the router is plugged into, and it sends our packet directly to the network's exit door. The packet has successfully navigated the local streets and has arrived at the front door, the router. Now it's time to leave the building and head out onto the vast public highways of the internet. And this is a perfect time to clarify a really critical difference. A switch is a local operator. It only cares about those physical MAC addresses and connecting devices on the same network. A router, on the other hand, is an inter-network navigator. Its entire job is to look at the logical IP address and forward packets between different networks. It's the gateway from your private little network to the massive public internet. So yeah, a router is way more than just a simple door. It's an intelligent decision maker. It keeps a routing table, which is like its own personal map of the internet, to figure out the best path for our pocket. It also acts like a security guard, making sure that local chatter, like those ARP broadcasts we just talked about, doesn't spill out and flood the entire internet. And now our packet is out in the wild. It has left the safety of your local network and is now traveling across this massive interconnected web of routers that makes up the internet. This is by far the most complex leg of the journey. You see, the internet isn't static. It's changing like every millisecond. And to deal with this, routers use something called dynamic routing. You can think of it like a giant, real-time GPS for all the data in the world. This dynamic nature is the secret to the internet's incredible resilience. If one path gets too congested or a cable under the ocean gets cut, the network automatically and almost instantly reroutes all the traffic, healing itself without us ever even noticing. So our packet doesn't just make one giant leap to the destination server. Instead, it takes a series of hops. At each router it arrives at, its IP address gets examined. And that router makes a brand new, independent decision about the best next router to send it to. This journey could involve dozens of these little hops across different cities, different countries, even different continents. After hopping all across the globe, our packet finally arrives at the destination network. The journey is almost over. It's time to deliver the message, get the reply, and then head all the way back home. So once the packet arrives at the destination server, that whole encapsulation process we started with just happens in reverse. It moves back up the OSI model. The data link layer strips off its frame, then the network layer removes the packet header, and the transport layer takes off the segment header. It's just like unpacking that suitcase, layer by layer, until only the original request from your browser is left. The server now has your request. Send me the homepage. It gets that data ready, but before it sends it back, it shoots off a quick little acknowledgement, or ACK. This just confirms that your packet arrived safely. See, communication is a two-way street, and this process ensures nothing gets lost. Then it sends the web page data back on a reverse journey of its very own. And the total time for this entire incredible round trip, on a decent connection, we're talking about 50 milliseconds. Faster than you can blink. That includes the packaging, that local address query, the journey across dozens of routers all over the world, the unpacking, and the full reply coming all the way back to you. I mean, just let that sink in. A super complex journey involving dozens of devices, layers upon layers of protocols, thousands of miles of cable, all completed faster than you can blink your eye. It is an absolutely incredible feat of engineering that happens trillions of times every single day. So the next time you click a link, just take a second to remember the incredible journey your little data packet is taking. This complex, high-speed system is the foundation for almost everything we do online. And it kind of makes you wonder, right? What other invisible, lightning-fast systems are working all around us, powering the world we live in?